A probe has been sent to explore the depths of the massive planet Jupiter, and the results are astounding. The discovery made is unexpected and will leave you questioning everything you thought you knew about our solar system. This scientific discovery unveils the truth of one of the most mysterious planets in our galaxy. Will our understanding of Jupiter and its place in the solar system be forever changed? Watch the video till the end to find out.
Audio Jungle.
On August 5, 2011, Juno spacecraft launched on a 5-year trip to Jupiter, the biggest planet in our solar system. After a 5-year, 1,740 million mile voyage, Juno arrived at Jupiter on July 4, 2016, and settled into a 53-day polar orbit, ranging from just beyond Jupiter's cloud tops to the outer regions of the Jovian magnetosphere. Juno gathered more than 3 terabits of scientific data and gave stunning pictures of Jupiter and its satellites during the main mission's 35 Jupiter orbits, all of which were analyzed by citizen scientists using NASA's first-ever camera devoted to public outreach. Juno's many findings have altered our understanding of Jupiter's atmosphere and interior, showing a deep interior with a dilute heavy element core and an atmospheric weather layer that reaches well beyond its water clouds. Flybys of the moon Ganymede started Juno's transformation into a complete Jovian system explorer towards the conclusion of the primary mission, when the spacecraft's orbit expanded. Juno will continue its exploration of the solar system's biggest planet until September 2025, or until the spacecraft's end of life. Juno will now be tasked with exploring the whole Jovian system, including Jupiter, its rings, and moons, with further encounters scheduled for 2 of Jupiter's most fascinating moons, Europa and Io. The findings of NASA's Juno spacecraft, which were disclosed in October 2021, present a more complete picture of what's going on underneath the clouds. Juno data suggest that Jupiter's cyclones are warmer at the top with lower air concentrations, and colder at the bottom with greater densities. Anticyclones are cooler at the top but warmer at the bottom because they spin in the opposite direction. These storms are also far higher than predicted, with some reaching 60 miles below the cloud tops and others, such as the Great Red Spot, spanning over 200 miles. This surprise study shows that vortices extend beyond the areas where water condenses and clouds form, and beyond the depth where sunlight heats the atmosphere. Because of the Great Red Spot's height and extent, the concentration of atmospheric material inside the storm may be visible by equipment monitoring Jupiter's gravitational field. 2 near-Juno flybys over Jupiter's most renowned region allowed researchers to look for the storm's gravitational signature and add to previous findings about its depth. The Juno crew was able to confine the Great Red Spot's size to a depth of around 300 miles below the cloud tops using gravity measurements. Jupiter is well known for its unique belts and zones, which are white and reddish bands of clouds that wrap around the planet. The bands are separated by strong east-west winds, blowing in opposing directions. Juno previously revealed that these winds, often known as jet streams, reach depths of around 2,000 kilometers. Researchers are still attempting to figure out how jet streams develop. Juno data from numerous flights offer one probable clue. Ammonia gas in the atmosphere flows up and down in amazing synchronization with known jet streams. The findings from Juno also suggest that the belts and zones change roughly 40 miles under Jupiter's water clouds. Jupiter's belts are brighter in microwave light than adjoining zones at shallow depth. However, at deeper depth under the water clouds, the converse is true, revealing a likeness to our oceans. Polar storms. Juno previously observed polygonal patterns of massive cyclonic storms near Jupiter's poles, 8 in an octagonal pattern in the north and 5 in a pentagonal pattern in the south. Mission scientists discovered that these atmospheric occurrences are remarkably robust, lingering in the same position throughout time. Juno data also shows that, similar to hurricanes on Earth, These cyclones try to migrate poleward, while cyclones at each pole drive them back. This balancing describes the location of the cyclones and the varied numbers at each pole. Several publications on Juno's atmospheric findings were published in the journals Science and Journal of Geophysical Research, Planets. Other publications were published in 2 recent editions of Geophysical Research Letters. These fresh Juno measurements provide a vast collection of new information about Jupiter's intriguing visible characteristics. Each article provides light on distinct parts of the planet's atmospheric processes, and it's a great illustration of how our globally varied research teams help us comprehend our solar system. After all these discoveries, and as the truth unfolds, is our society ready to accept it? Following Juno, the European Space Agency's ESA first large-class mission in its Cosmic Vision program, JUICE, will launch Jupiter Icy Moon Explorer. It is scheduled to launch from the Guiana Space Center in French Guiana in 2022 and will arrive at Jupiter in 2030. JUICE will thereafter spend 3.5 years monitoring Ganymede, Europa, and Callisto, 3 of the 4 Galilean moons, as well as Jupiter. Because all 3 of these moons are thought to have large quantities of water under their surface, the JUICE mission will investigate their habitability in detail. Another mission to Jupiter is the mission to Europa, with multiple flybys. The Europa Flyby mission spacecraft, originally known as the Europa Clipper and consisting of an orbiter and a lander, is the next scheduled mission to Jupiter. It is scheduled to be released in the 2020s, with the earliest target date presently set for 2022. The initial concept intended for the vehicle to be placed in Europa's orbit, but due to the intense radiation from Jupiter, it was eventually chosen to circle Jupiter and then pass by Europa on occasion. If launched on the Heavy Lift Space Launch System, this spacecraft would arrive at Jupiter in slightly under 2 years, although the length of the scientific phase has not yet been determined. Observer of the volcano Io is one of the other missions on the discovery of Jupiter. The Io Volcano Observer, IVO, is a projected robotic spacecraft presented by the University of Arizona and Johns Hopkins University's Applied Physics Laboratory as a NASA Discovery Class mission in 2010 and 2015, as well as a contender for NASA's New Frontiers program. If IVO is chosen for the 13th mission, it will launch on May 29, 2021, with NASA determining the newest Discovery Class future mission by September of 2016. IVO would transit Jupiter for 5 years with an orbital insertion date of February 2026, followed by a 22-month research phase with at least 8 orbits. Another mission is known as the Most Advanced Jovian Asteroid Explorer. The AJAX is the most recent planned spacecraft for the Jupiter system, and it is also a candidate for NASA's projected 13th Discovery Class mission. It would follow the same time frame as the IVO with a possible launch date of 2021. AJAX's purpose is to combine flybys, orbits, and landings into a single mission to examine one of Jupiter's Trojan asteroids. Well, there you have it. The unexpected discovery made on Jupiter has shed new light on the planet's atmosphere, magnetic field, and the potential for subsurface oceans. It is a reminder that our understanding of the universe is always evolving, and that there is still so much to be discovered. We hope you enjoyed this journey of scientific discovery and that it has sparked a curiosity in you to learn more about the incredible world around us. Thank you for watching and stay tuned for more groundbreaking discoveries in the future.